Hello students, today we will discuss about relays. This is lecture 3 part 1. In this lecture uh, we will focus on relays basics, and in next lecture we will discuss about different type of relays, their operation in details, stepwise. Uh, Now the question arises that what is relay? As we know that relay is an integral part of any protection system, and it is widely used in industries and also in domestic purposes. So if you want to define a relay in simple words, basically relay is an intelligent electronic device uh, used in protection of electrical power system. A relay typically sends voltages or current in its protection zone. It is programmed to give trip command to the tripping coil of the circuit breaker if it sends a huge amount of current or abnormal voltage. By this trip command, circuit breaker uh, interrupt the circuit and isolate the faulty section so that the rest of the power network remains stable. Classification of relays. Relays can be classified in different directions. For example, we can classify relays on the basis of a structure. We can classify relays on the basis of functions, and we can also classify relays on the basis of characteristics. Uh, if first we talk about classification on the basis of structure, so uh, we have two main categories, subcategories. There are other categories, but the two major categories are electromagnetic relays and the solid state relays. The first type is electromagnetic relay. Electromagnetic relays are constructed with electrical, mechanical, and magnetic components and have an operating coil and mechanical contacts. Therefore, when the coil gets activated by a supply system, these mechanical contacts get open or closed. Uh, if we talk about its construction, usually an electromagnetic relay has two circuits, low voltage control circuit and high voltage working circuit. The low voltage control circuits includes an electromagnetic relay coil or a low voltage power supply and a switch. Uh, the high voltage working circuits includes a high voltage power supply, uh, a motor, and the contacts of the electromagnetic relay. Uh, the working principle of the electromagnetic relays is not complicated, and of course it's not new, but it operates mainly according to the principle of electromagnetic induction. Switching on the power in the low voltage control circuit, the current goes through the coil of the electromagnetic to generate magnetic field. Then the armature generates a suction force to making the movable contact and stationary contact touching. The second type is solid state relays. Solid state uses solid state components to perform the switching operation without moving any parts. Since the control energy required is much lower compared with output power to be controlled by this relay, that results the power gain higher when compared to the uh, electromagnetic. Along with that, the size of solid state relays is smaller than electromagnetic relay. Uh, a solid state relay is a non-contact switch fully composed of a solid state electrical element which can drive high current load with a small control signal. It can achieve switching uh, on and off with no contact and no spark due to the switching characteristic of electrical element. These elements can be semiconductor components like transistor, triacs, dioc, and many other power electronics components. Solid state relay uh, has many advantages over electromagnetic relays: high reliability, no contact, no spark, long life, fast switching speed, uh, strong anti interference ability, and of course, as we discussed earlier, size. Uh, it has widely used in the applications like CNC machines, remote control system, industrial automation devices, chemical industries, medical equipment, and you can name them. Any industry is now using solid state relay due to its uh, advantages. Solid state relays can be divided into AC solid state relays and DC solid state relays that of course can be used according to applications. Now we will discuss the relay classification on the basis of functions. As we discussed earlier, that relay can be classified into the several directions. So if we talk about functions, there are five basic functional types that are protective, regulating, synchronism check, monitoring, and auxiliary. In next slides, we will discuss each of the type in detail. Now we will discuss about protective relays. As the name suggests that it is basically used for protection purposes, we can say the protection of generator, buses and other components. Protective relays and the associated system that are fuses operate on the intolerable power system conditions and are the main uh, thrust of this course. They are applied to all parts of the power system. You can say generators, buses, transmission lines, transformers, your distribution systems, distribution lines, feeders, motors, reactors, capacitor banks, and much more. For the most part, uh, the relays discussed are a separate device that are connected to the power system through CTs and VTs that we discussed in our last lecture. From the highest system voltage, like in Pakistan, we have up to the mark of 500 kV. So in different countries, there are different voltages level like 765 kV down to the service level of 480 volts or 220. Um, in general, distribution equipment below 480 volt and in somewhere 220 volt is protected by fuses or protection devices that are integral with equipment. Now the second type is regulating relays. Regulating relays are associated with tape changes on the distribution transformers and also the power transformers, um, and on voltage regulators of generating equipment to control voltage level with varying loads. As we all know that the voltage can be vary in different situations, so we have to regulate them according to our need. Regulating relays are used during normal system operation and do not respond to system faults unless the faults are left on the system far too long. Well, this is not normal. And one more example I can quote here is AVR. In generators, We have AVR, automatic voltage regulator, that controls the voltage. One more example, you can say the digital stabilizer, which can be controlled electronically. So the voltage regulators or voltage regulating relays are also used there. Well, the next one is synchronism check. You can also call it reclosing, and also synchronizing relays were formerly classed as programming, but because this term is now widely used in different context as related to computers, a name change has been made. Well, the relays of this type are used in energizing or restoring lines to services after an outages, and in interconnecting pre-energizing energized parts of the system. Like for example, if there is a complete blackout, if we have to restart our systems, generation systems again, so we have to sync it on a one single frequency. This is the basic example of this type of relays. The fourth one is monitoring relays. Monitoring relays are used to verify conditions in the power systems or in the protective systems. For examples, we have examples in power systems are fault detectors, voltage techs, or directional sensing units that confirm power system conditions, but do not directly sense the faults or trouble. Uh, in a protection system, they are used to monitor the continuity of circuits such as pilot wires and trip circuits. In general, alarm unit serve as monitoring functions. So, in generating systems, we have different type of monitoring relays that monitors the whole system and generate alarms when it exceeds to a certain value or that is already defined. The fifth one we have is auxiliary relays. That auxiliary units are used throughout a protective system for a variety of purposes. Generally, there are two categories. Number one, that is contact multiplication, and the other one is circuit isolation. In relaying and control systems, we can say there are frequent requirements for each. For example, more outputs for multiple tripping alarm and operating other equipment such as recording and data acquisition, or you can say the second one, contacts that will handle higher currents or voltage in the secondary systems. Um, you can also say is the trip and closing relay used with the circuit are called as auxiliary relays. And now the classification on the basis of characteristics. Uh, Number one, we have inverse time relay, IDMT relay with instrument step characteristics, program switches, and definite time relay. Well, students, uh, when we progress in these upcoming lectures, we will define each and every relay in complete details. For here, we can only categorize, or we just want to look at that how relays are being classified. So in next our lectures, we can say we will do complete description of each relay, and plus we have some sort of numerical details also. Well, if we classify on the basic of logic, so we have like differential, unbalanced, neutral displacement, direction, restricted earth fault, overflexing, distance, and reverse power relay. loss of excitation, negative phase sequence. Students, there are numerous type of relays and their logics which are implemented in industries. So we have not much more time to study all of these. So I have selected some of the relays that we will do in our next lectures. For example, we have reverse power relay. So a reverse power relay, loss of excitation, these two relays are basically used in any generation or generating stations, like any generator loss its excitation. So this relay operates. Likewise, we have distance relay used in the protection of the transmission lines. Well, if we talk about transmission lines, we have to trace the location of the fault. So distance relay will be used for this purpose. Well, reliability and protection standards. With the significant structural changes that have been evolving within the electrical power industry, it has been recognized that standards and procedures needs to be developed in order to facilitate effective market operation and to ensure the reliable power operations. Reliability standards have existed for planning and operating power systems for many years. Uh, Compliance with these standards has been open to interpretation and it's voluntarily in nature. It is also considered mandatory that the technical requirement relating to the types of equipment being installed, along with the manner in which it is connected, operated, and protected, to be documented. So it is very necessary to we have some sort of codes, like in the protection area, a variety of ANSI, American National Standards, or and other one is IEEE or IEC. The three different organization standards has been developed over the years and continues to be developed as conditions change. Uh, these standards ensure that the complete protection of the systems remains unchallenged. If we talk about like for bulk power facilities, the reliability standards are typically built around the important objectives of the protection systems we will define in our next slide. As we discussed in the last slide, there are some objectives, I can say the important objectives of protection systems, as like when we have preventing or minimizing equipment damage. While equipment damage can be costly to the owner, such outages also present challenges to the operating reliability of the power system. Secondly, minimizing the scope and area of an outage following a system fault. Along with that, assuring that faults are detected and cleared in time frame such that the power system remains stable. Uh, Allowing power system facilities to be loaded to their full normal and emergency ratings. Um, for example, students, operation designs of bulk power systems are such that as minimum the system must remain operational upon the sudden or unexpected loss of any single facilities on the system. The system operator will alter the generation, dispatch, or the configuration of the system in order to maintain or remain within these operational criterias. The major objective of the protective system must remain intact for the failure of any device associated with a protective system. This constraint typically required the use of a two independent protection scheme for each protected facilities or as per requirement. uh, so we can say that these are the guidelines of the objectives of any reliable operations or according to the standards. Like we have a standard body like ANSI, American National Standard. Um, for relays, it has different standards, and it uh, named different type of relays on the basis of numbers. In the design of electrical power systems, the ANSI standard device uh, C37.2 denote what features a protective device supports. Like earlier I said, there are numerous type of devices used for protection, and to cover all of these devices it's not possible. So some of the devices that are used mainly we will discuss about their uh, code number, so we can identify if these devices are installed in any industry. Like some of the ANSI device number, um, like we have 27 for under voltage relay, 21 for distance relay, 14 for under speed relay, and so on and so forth. There are number of devices. So the point to be remembered here, when we talk about single line diagrams that you get in industries for the system reading, so you don't need to write name of the relay. They can be specified on the basis of these numbers. So as the time proceed, you will see that you will memorize these numbers. Because to memorize at this point is not necessary, but to have a basic understanding is necessary. Along with that, as I mentioned earlier, that in single line diagrams, the name of the relay in the most cases is not mentioned. There are only the relay number is mentioned. So the engineer has to identify the relay on the basis of the number. So these device numbers are also important. Along with that, if you procure any device, so these are the standards. Like 20, if 27 is a under voltage relay, so it will never change into the distance relay. It will always remain the under voltage relay. So in procurement you have to also get don't worry about that. Just you have the sheet of the device numbers, and you can provide that sheet to the procurement man. So you will get ease in the procurement. uh, there are some protection requirements that must need to be followed, and you can say the information for any application. So one of the most difficult aspects of applying is often an accurate statement of the protection requirement. This is valuable as an aid to a practical, efficient solution, and is particularly important when assistance is desired from others who might be involved or might assist in the solution, such as consultants, manufacturers, and uh, other engineers. Uh, this checklist, you can say, is basically the minimum required information um that you need uh, for the following whenever you have installing any protection systems. Or so this have single line diagram of the system, impedance of the power equipment, new and existing protection problems, operating practices affecting the protections, important of the protection, system fault study, and the maximum load and system swing limits. Along with that, the CT and VT location or connections. So if we discuss these protection requirements briefly, for example, we have the single line diagram of the system. As I mentioned earlier, the single line diagram is important. Um, a single line diagram for application consideration for a three phase systems or panel wiring, documenting the area to be studied and the surrounding system should be available. The location of the circuit breakers, generators, buses, taps, transformers, lines, all are present in this single line diagram. So it is the main or major necessary component. The second one is like impedance of the power systems or power equipment. Most of this information is usually included on SLDs, that is single line diagrams, but often omitted are the connections and grounding of the power transformers, banks, and the circuit impedance. Like phase sequence is necessary when a three line connection diagram is required. Requirement is like new, existing, and protection problems. Uh, if it is a new installation, uh, this point does not apply, but should be indicated. If not new, such information about the existing protection and any problems may assist updating or integration with the changes desired. Like if there is an extension of any industries, so the existing protection system must be studied. The second one is the operating procedures and practices, like addition or changes should conform to the existing practices, procedures, and desires. When these affects the protection, they should be indicated. Often, this can be accomplished by indicating that certain types of equipment or practices are unacceptable. Well, importance of the system equipment that is being protected. This is often apparent by the system voltage level and size. For example, uh, a high voltage transmission line are usually protected by high speed pilot protection, and the low voltage system by the time uh, over current protection. However, this should be clarified according to the desires of the protection engineers or the requirements of the systems. The second one is the system fault study. A fault study is important for the most protection application. For phase fault protection, a three phase fault study is required. Uh, so online information concerning a fault on the line side at an open breaker is frequently important. Uh, the fault study or the fault analysis, you can say, may be done by using different softwares, and the online softwares are also can be used. The other one is maximum loads and system swing limits, like the maximum load that will be permitted to pass through the equipment during the short time or emergency operation for which the protection must not be operate should be specified. Uh, I can say these are the limits of the device that is already mentioned on the data sheets, and for a complete system uh, the engineer should specify it. The other one is current and voltage transformer locations. This information is often shown on the single line diagrams, as we mentioned earlier in our first point, but uh, often the data are incomplete or unclear. Where multi ratio devices exist, the specific tape or ratio in use should be specified. Well, these are all specifications or requirements. I can say these are the prerequisites for developing um, healthy protection system. Well, there are some principles of the relay application. The power system is divided into the protection zones defined by the equipment and the available circuit breakers. Six categories of the protection zones are possible in each power system, like if we can say generators and generator and transformer units. Number two, transformers. Number three, buses. And number four is lines. Lines can be transmission, sub-transmission and distribution, all are included. Number five is utilization equipment that contains motors, static or other loads. And the other one is capacitor or reactors bank when separately protected. Well, you can see in the figure there are different protection zones depicted uh, that we studied earlier in the last slide. The fundamentals of the protection are quite similar of these six categories. Has protective relays specifically designed for protection that are based on the characteristic of the equipment being protected. The protection of each zone normally includes relays that can provide backup for the relays, protecting the adjacent equipment. The protection in each zone should overlap in that adjacent zone. You can see we have the unit generation generator transformation zone, transformer zone, bus zone, line zone, and in the second figure, which is same, you can see the sub transmission line zone, bus zone, transformation zone, and along with bus zone and motor. You can see this is the complete hierarchy, or you can say that it will start from the generation to the last section is motor section. Uh, well, these are the complete setup which are present in every generation to transmission, and transmission to distribution, and distribution to local industrial distribution setups. We can say that these figure are basically relay primary protection zones that you can mention in a power systems. So that's all from the relays basics. In our upcoming lectures, we will focus on each relay. Thank you very much.